So this video will be talking about gas laws. Now the thing you have to realize about the word law is that it is a simple equation. It's not something that's always true. As a matter of fact, none of these equations are strictly true when you look at the exact measurements. So Boyle's law, now you don't have to know the name of the person associated with the law, but you have to understand what they discovered. And Boyle discovered that the pressure of a gas times the volume of gas is a constant if you keep the temperature and the number of gas molecules the same. So for example, if you have a piston, like a bicycle pump, and you press down on it, you're shrinking the volume, but the pressure goes up, okay? And so that's why, and they're inversely proportional to each other. So the pressure times volume is a constant, which means that if you take a gas at one pressure and one volume, and you change it to a different pressure and a different volume, keeping the temperature and the number of molecules the same, then this equation would be true. Now, in this case, it doesn't matter that the pressure units need to be atmospheres or anything else. All that's required is that they be exactly the same unit, and the same goes for volume. As long as they can be the same unit, you don't have to transform the units, although that's generally a good practice. All right, so Charles, he was a person who really did a lot of work with hot air balloons, and he discovered that if you heat air up, it expands, gets larger, and makes the balloon much larger and less dense than air, and hence it would float in the air. So Charles' law, he more or less discovered that the volume is proportional to the temperature if you use a temperature scale like Kelvin. So Kelvin is actually called the absolute temperature. Okay, so the smallest volume you can get for a gas is 0 at a temperature of 0. Now, of course, we actually don't get gas all the way down at temperature 0. They condense to liquids and then freeze before anything like that happens. Okay, and the other reason the volume can't be 0 is because the molecules, even though they occupy a very small fraction of the space of a gas that we're familiar with, if you cool down a gas, its volume will shrink, and eventually the volume of the molecules becomes important. We can't assume that it's all empty space. All right, so if that's the case, then the volume at any one temperature and is going to be equal to the volume at a different temperature. And so you can set up that equation. All right, and so GasLaw1, he's the person who discovered that if you compress a gas, it'll actually heat up. And so this is actually how your air conditioner works. And so there's a compressor in your air conditioner. It compresses the freon, which generates heat. And then that heat is removed by a radiator of some sort. And then it re-expands the gas to a low pressure, and then it gets cold. So anyhow, what this means is that you can have a problem where if the volume, that's the pressure and the temperature. Okay, so P1 over T1 is equal to P2 over T2. You could write an equation like that if you wish. Now, the easiest way to work these sorts of problems is go ahead and use what's called the combined gas law, or even the ideal gas law, which we're going to talk about later. So we've more or less combined the fact that PV is a constant, the pressure over temperature is a constant, and the volume over temperature is a constant, and saying that pressure times volume divided by temperature is equal to constant, which allows you to write, for example, this equation, P1 V1 over T1 equals P2 V2 over T2. So all of these problems are very simple. So basically the first sections of Chapter 8 are variations on these, and then later on does the combined gas law. So we're just going to work one of these, and you should be able to work out the rest.